Let us try to see how we can make the SR latch using the NAND gate. Okay. We already have discussed, like if I'm able to connect the output of one NOR gate with the input of the second NOR gate, and the output of the second NOR gate to the input of the first NOR gate, and we can keep two inputs as a input, like input of both the NOR gate as a input, like that can be the reset and the set. And we can take, like suppose if I'm taking this as a reset input, so I just told you the output of that flip-flop is nothing but that will be the QT. Okay, and similarly if I'm taking this as a set input, so this term, this is nothing but this will be the QT complement. Okay, so this is what we have seen in the previous slide. Now this design was nothing but this is based on the NOR based structure. Okay, but let us try to see how we can make it the NAND based structure. To make it NAND based structure, we can simply apply the De Morgan theorem on at these points. Like we know that the NOR gate is nothing but, like if you have a two input NOR gate, then this is nothing but this can be written as the bubbled AND gate. Okay, this is nothing but this is the bubble, and this is what the De Morgan theorem says. Okay, so based on that, what we have done, we have just, so let us try to see how we can replace these things. So we can replace this first NOR gate with the help of bubbled AND gate. Similarly, the second NOR gate can also be replaced with the bubbled AND gate, bubbled AND gate. Okay, and now and the output will be connected to the input. So now if we see here, if we closely relate these two circuits, this is nothing but this is the R. Okay, this is what R is. Similarly, the second input is S, and this one is the QT, and this one is the QT bar. Okay, so this is what we can simply write just like we have done in the previous circuit. Now, but because I have to make it with the help of NAND gate, so how it could be done? So let us try to do something. Suppose somehow we can shift this bubble to here, then this will become something like, if I remove this bubble, then the structure will be something like this. I will be having a structure something like this. This will become like this. Okay. And the second thing what we can do, and here I will get only this kind of a structure. I will have this kind of a structure here. Now, second thing what we can do, because this inverter is nothing, this bubble is nothing but this can be controlled with at this point. So what does it mean? It means that we can make this bubble at this point. Okay, if we are able to make this bubble at this point, so both will become the NAND gate. Okay, so let us try to see how it will become. But yes, of course, because this inverter will help to make this gate as a NAND, and this inverter will help to make this gate as a NAND gate. Okay, now because we have another two inverters that are placed here, which are bubbled here and bubbled here. So if we are getting something like that, the resultant circuit will be like this. Okay, where we will have, yeah, because this complement in R, that it simply means that the input of this is nothing but this is the R complement. Okay, after passing through the bubble, I will get the complement of that one. Okay, so here I will have R complement, here I will have the S complement, and at this point I will get the QT, and at this point I will get the QT complement. Okay, so what does it means? It means that suppose if I am making any NAND gate with the help of SR latch with the help of NAND gate, in that case the inputs will be complemented as compared to the NOR based design. Okay, so this is a very important point that you should consider, or you should know. Okay, so this is how it is different and how it is important to understand. Okay, so this is what we have done. So the resultant circuit that will look like this one. So this will be the final circuit. Yeah, after just twisting here and there, nothing but this design has been made in a different way, and this is nothing but R bar, S bar, and something like that. Okay, so this is what you can make it. Okay, so this is how the output will look like. Yes, I think there's some mistake over here. Mistake is like whatever the QT was here, QT was the output of this NAND gate. So here it should be the QT and here it should be the QT complement. Okay, so please correct this thing. Okay, so this is how we can make it. Okay, so if you see here, if you see this particular diagram, whatever we have made over here, this diagram, like the QT plus 1, that will look like, let us see, if I'm considering, yeah, you can do anything like for this particular circuit, you can consider this as a QT bar, this as a QT, or vice versa. Both are possible, but we got to make it symmetrical. We need to consider this as a QT. So I need to remove, I don't need to consider this bubble, this bar. So let me make it something different. So one of the output is this one, and the second output is this one. Okay, so these are the two outputs. Okay, here I will get the complement kind of output. Okay, so I need to make the complement over here. Okay, based on the whatever we have done here. Okay, so the exact output will look like this one. Write the expression for all these things, how the output expression will look like. Okay, so let us try to write the QT plus 1 expression. QT plus 1 expression for QT plus 1, which is the next state. Okay, so QT plus 1, that, yeah, so I'm just interested to calculate this QT plus 1, and this QT plus 1, that depends on the R bar and this input, which is the QT bar. Okay, so this is nothing but, and NAND means we simply multiply it and make the complement of it. So the QT complement into R complement to the complement will be the QT plus 1. Yeah, if we simplify this one, so we can make it the opposite one, like that looks like a before, which you can see here. Simply if you apply the Morgan's theorem over here, so you will get Q bar T plus Q bar T plus R bar, something like that, and bar that will be cancelled out, so you will get simply QT plus R, and this is nothing but this is same as what we have done before for the QT plus 1. Okay, so this is what you have already done it, so this is what you can expand it. Similarly, if you try to calculate the complement one, so QT plus 1 complement, that will look like, let us try to see how it will look like. QT plus 1 complement, yeah, we want to we are interested in at this output, and this output depends on the S bar, and the second one is the QT. So this is what we can write. This is the QT plus QT dot S bar complement. So this is the function for QT plus 1 which we should know. Okay, so this is all about how the expression looks like if we are interested to make SR latch with the help of NAND gate. Okay, yeah, so yeah, I think I need to write it properly. Yeah, so the next circuit can be, yeah, so I think I need to remove it. Okay, I need to write it again. Okay, because I have already written it, so you can check it out. So the next, suppose if I want to make this latch, whatever the latch I have, if I want to make it just like a cloud control, so we know that if we connect some AND gate to the inputs, and one of the inputs should be controlled to the clock, then that it becomes the cloud control, or that will become the latch. Okay, so to make it latch, I can use this NAND gate. Okay, and NAND gate means simply because here I have a R complement. Okay, and this bubble I have used, and yeah, simply if we can go back to the previous slide, and I can tell you what we have done here. Here what we have done, we have just connected a AND kind of a structure. Okay, and this AND structure is one of the input is reset, one of the input is set, and one of the input is common, which is the clock. Okay, so this is what we have already done. Okay, so let us try to replicate the same thing. Okay, so if we want to replicate the same thing, then the structure will look like this one. So here we have a R complement, so I can make it the R, and then yeah, simply this is how the actual circuit will look like: S and clock and QT and QT bar. Okay, so this is how it will look like. I think again we have made one mistake over it. It should be like the set output is the complement and the reset one is the non-complement. Okay, so this would be the complement and this should not be in the complement nature. Okay, so this should be the output. So this is how we can make a gated SR latch or SR flip-flop. So here what is the difference between the first circuit and the second circuit? These two circuits is like we have added the clock pulse. That is the logic is the clock controlled. Okay, so this logic is the clock controlled. Okay, so in case if you have any doubt, you can ask the question on this slide. If anyone has any doubt, then you can ask the question. Okay, there's no doubt. Yes, I relaxed the student to do that attendance is not mandatory. So attendance is less than 50%. Very good. You are doing very good job. Huh? Much appreciated. It seems you don't like to study, right? So okay, fine. Attendance is not important. Enjoy. I have already promised to myself that I should not consider attendance. Enjoy. You're really in IIT where you are getting very good relaxation. And you should be proud of yourself by missing the lectures and everything. This is really good. Do not attend the lecture, you will get the video lectures, you will get the PPTs, you will get the slides. Yes, I'm again say, see, initially I denied to share the PPT. Now onwards, you will get PPT as well. So how much spoon feeding you want? Let me know. I will do all these things. Be happy. Your happiness is more important for me. Okay. So at the end of each lecture, I will share the PPT. And this I think this was the complaint from your side, right? I don't need, I usually not share the PPTs, but other faculties are sharing. Okay, so let me remove this problem as well. So I think, and you can also tell me, like, if you want to say, tell me, like, you can also say, please share 20 questions, and out of that I can ask 5 questions. This is also possible. If you like, I can do this also. Okay, either 10 out of 5, this is also fine. You can ask 10 questions, and out of that I will give 4 questions. This is also doable. I can do that. Be happy, get A grades, everyone. Fine, thank you. Perfect. So as of now, whatever the latch we have studied, we saw like we can make it controlled with the help of clock. But suppose whatever the states, whatever, like, we know that any of the flip-flop that we have studied, these are basically is utilized to store a logic. Okay, flip-flop or latch are basically, the importance of these logics are to store the data. Okay, either it can store 0 or it can store 1. So if I am referring the QT as a storage node, so QT and QT bar are the complement in nature. Okay, so if these two are the storage nodes, so whatever the data I have stored at Q2, that will be considered the actual data, right? So suppose QT is equal to 1, so by default QT bar will become 0. Okay, so I will say this flip-flop has stored logic 1. Okay, and vice versa. Suppose it is storing 0 and the next one is 1, so we can say that this flip-flop has stored logic 0. Okay, so logic 0 and 1 is decided with the based on what is the value at QT. Okay, what is the value at QT? That is important. Okay, now suppose in case if I want to make it clear, if I want to preset or clear, preset means if whatever the data I have, whatever the flip-flop I have, if I want to make the initial logic that I want to store at the QT should be high, then I need to preset it. Preset simply indicates that if I want to store logic 1 at the reference storage node, remember the reference storage node is the QT, okay, and if I want to make logic 1 to the flip-flop storage node, in that case I need to preset it. So preset basically that says that how we can set the logic high to the storage node QT. If I'm talking about the clear, whatever the data I have stored, if I want to make the clear all the data which was stored in the memory, in that case I need to clear it. So all the flip-flop will have logic 0. Okay, so that it means we are clearing the things. So let us see if I want to include the preset in the clear kind of feature in the circuit. In that case, this is what we have already seen. This is nothing but this is the gated SR latch. Okay, this is what we have already studied before. Okay, this is nothing but this is the NOR gate based gated SR latch. And here we have used one structure just to control the clock pulse. Okay, but now if I just told you, if I want to make it preset, then how it could be done? Okay, so let us try to see here. We know that the expression for NOR gate is like, suppose I have a 2 inputs for the NOR gate, A and B. So the output is nothing but A plus B complement. Okay, so if any one of the input is like, if any of the input is 0, or if both the inputs are 0, in that case I will get logic 1 at the output. Okay, so how we can make the logic 1? Let us try to make some circuit, and then we'll get to know that if I have a NOR gate, so to make the output at logic 1, all the inputs must be at 0. Let me repeat it again what I'm saying. All the inputs must be 0 to make it logic 1 at the output. Okay, or simply you can also replace this with the bubbled AND gate. Okay, so this is also possible. So if two inputs are there, then the bubbled AND gate will be there. You can replace it with this one also. Okay, so now let us try to see how the clear and preset signal works, and how actually we can make them the clear and the preset. Okay, so let us try to see here. Suppose I have one input which is the clear. If you see here, if I have to clear the data, okay, if I have to clear the data, what I have to do? I just told you, to make this Q as a high, I need to make all the inputs that should be 0. If all the inputs are 0, then this will be high. Otherwise, in other case, like it should be 0. Okay, so suppose so what will happen? Let us assume whatever the input I am getting here initially, let us assume QT was 1. Okay, initially QT was 1. So QT complement will by default it will be 0. What it means? This QT bar is connected to this point, which is the 0. Okay, this is nothing but this is the 0. Now let us see if the clock is equal to 0 or clock is equal to 1, whatever. But let us assume it is the clock is equal to 0. Okay, so again I will get the 0 over here. Okay, and let us assume the clear pulse was 0. So if 0 0 0, then this QT should be 1. Okay, but if I want to make it 0, like output of this flip-flop should be 0, in that case I need to activate at logic 1. So if I want to make this QT to logic 0, I need to activate this clear input, so that the output will become 0. Okay, so this is how we can clear these things. Similarly, the preset works. So like if I am considering the QT output to make it clear, so similarly, I can consider the Qt complement output to make it preset. Okay, so the preset inputs are generally connected towards the Qt complement, and the clear inputs are generally considered at the Qt side. Okay, so yeah, before I just discuss all these things, let me explain the truth table, and that your doubt will be clear if you have anything. Okay, so if you have any doubt, that will be cleared here. Okay, so see, let us try to see here. The first thing is, okay, if the clock pulse is equal to 0, okay, let me change the color. If clock pulse is equal to 0 and preset is equal to 0 and the clear is equal to 1, okay, this is the first case where we are considering the clock is equal to 0, preset is equal to 0, clear is equal to 1. If this is the case, then whatever the input of set and reset will be there, it does not matter, because the clock is 0 means this is AND gate, so AND gate will give you like the output is nothing but clock into S, and here it will be like clock into reset. Okay, these two are the outputs of this AND gates. Okay, and this is one of the input of this one. So whatever the input, like if the clock is equal to 0, by default you will get a 0 0 over here. Okay, and even though we are changing set and reset, it does not matter. What if the clock is equal to 0, this output of this AND gate will always be 0. Okay, so if clock is equal to 0, it does not matter what is the set and reset, that will be 0. And now let us consider if the if this is the case, then what output I will get. If the clear is equal to 1, clear is equal to 1 means you need to just check how it is happening. You will clear the data, means the output Qt plus 1, Qt will be 0 because we have cleared it. Okay, so this is nothing but this is the clear. Okay, you can check it out how it is working. Let me tell you again. This output and this output will become 0 if both are 0. And let us consider it was Qt, before it was Qt and it was Qt complement. So if I have made this preset is equal to 0, so this is 0, and let us assume whatever the value I have, let us assume it was 1, so it will be 0. Let us consider this stage. Okay, so 1 0 0, that will give you the 1, and because you are making yeah, so sorry, I made, yeah, so if you are making a preset is equal to 0, in that case preset is 0, so 0 0 0, that will give you the logic 1. And if you are making clear is equal to 1, so by default, because any one of the input of this NOR gate is 1, if any one of the input is 1, then by default the output will be 0. Output will be 0. What it means? The data will be cleared. Let me repeat it again what I did here. Okay, see here, initially I'm considering the clock is equal to 0, so by default the output of this AND gate will be 0. Okay, and I'm considering the Qt is equal to Q was, let us assume it was 1, so by default Q complement will become 0. Okay, now let us see, if I'm making the preset is equal to 0, preset is equal to 0 means the 0 input will be here, 0 input will be here, but 1 will be here. So 0 0 1, that will give you the logic 0. So here I will get 0 0 1, and now if you see the first OR gate or NOR gate, here I will get, because I have considered 0 here, so 0 will be here, 0 will be here, and the 1 will be here. Okay, so 0 0 and 1, we made some mistake. 0 0 and 1, Qt was 1, so whatever the Qt was, that was controlled, and 0 OR gate. output of NOR is like that will become 0 plus 0 plus 1 complement. Perfect. So I made a mistake here. So if I'm clearing over here, so the clear will simply 1 plus 0 plus 0 and the complement, that will become 0. So what it means, we will clear it and the rest that will be complemented. Okay, so the next state will here it will be the complemented, but here it will be clear because we have activated through this one. So the clear and preset input that decides like whether I have to clear or the preset. Okay, similarly if you see the second case, next case, the next case would be like if I activate the preset. So how it will happen? Let us assume the clock pulse is equal to 0 and the set and reset are don't care condition. I have preset it, I have clear is equal to 0. So in that case, nothing but the QT plus 1 will become 1, and that is nothing but this is the preset. So just you check it out and you will get the same kind of QT plus 1 will become logic 1. Okay. Similarly, we can have other cases like if clock is equal to 1, then it will depends on the S and R. Okay, so that we can have a 4 possibilities: 0 0, 0 1, 1 0, and 1 1. Okay, here we have a 4 possibilities, and accordingly you can make it clear or preset. Okay, so if both are 0 0, so let us assume this is the case to clear and preset. But if clear and preset are 0 0 0 0, so they will act as a normal flip-flop, which we have already discussed, because we are already providing the logic 0 to the inputs. So if 0 0 0 will be there, then the previous state will be considered. That is nothing but it is the QT. So this will be the previous state. Okay, next one is if S and R are 0 and 1, then because we have reset is activated here, so it will be 0. Next case, it means it will be reset. Okay, it will reset. Next one is if you see the third case, set is 1, so it will set the output. What it means, the output will be 1. And if 1 1, then again it is the indeterminate state, which is the don't care condition. Okay, the race around condition. What is the race around condition? I will discuss you in more detail. So this state is nothing but this is the indeterminate state. Okay, so these all are the state for these flip-flops. If you have any doubt, you can ask the questions. Otherwise, we can move ahead.